Hello, guys. We're going to be starting out with the second part of this chapter, which is the foundation of the climate change. Okay, and in this section, we're going to be talking about the greenhouse effect. The first point, greenhouse effect, and what are the different types of greenhouse gases. And we're going to be looking at an overview of it. And gradually, we will move towards the shared socio-economic pathway. That is also an important section for the exam. Let us move toward the greenhouse effect. Let us first talk about the greenhouse gas. Okay, now why do we term something as a greenhouse gas? Because ultimately, whatever is the heat that is coming towards the earth, okay, and if there are certain gases which are actually restricting that heat, okay, or they have the capacity of restricting those heat or absorbing those radiations, then we are terming them as a greenhouse gas. Okay, so if you look at the basic definition over here, the greenhouse gas, primarily the important word to remember for the exam is something which can absorb the infrared radiation, okay, which is coming towards the earth. Now, when we talk about the greenhouse effect, it primarily tells you that greenhouse effect, looking at the diagram which is there on the right hand side, they have shown you two different pathways. Okay, one side, if you look at the first side, the CO2 in the atmosphere is very low, and that is why what is happening, the more and more heat which is coming towards the earth, it is also going back. But when you see over here in this diagram, then when there is more and more CO2, which is represented with the red surface, that essentially means that there is high number of greenhouse gas, or the quantity of greenhouse gas is very high, which means that more and more gas, more and more heat is getting trapped within the earth atmosphere. It is not going outside. So whenever there is higher greenhouse concentration on your atmosphere or a climate, it essentially means that the heat which is coming towards the earth, it will stay within the earth atmosphere. Okay, and it will warm up the climate of the planet. So greenhouse effect primarily means that warming of the earth's planet surface, and this is happening because of the greenhouse gases. Now, what is the impact to it? When the temperature on the earth is going to increase because of those greenhouse gases, the atmosphere will lead to more and more heat within it, and leading to higher temperature. And we know because of the high temperature, the ice caps are melting, the sea level is increasing. That is the effect. So this slide primarily focused on two things. What is the greenhouse gas and what is the greenhouse effect? Let us move forward towards the general discussion on greenhouse gas. Now, when we talk about composition of the atmosphere, what is happening over here is that in the atmosphere, there are a variety of gases which are available, like oxygen, molecular nitrogen, and all of that. But not majority of them, they do not interact with the infrared radiation. What it simply means, they do not have the capacity to absorb infrared radiation. And there are certain specific kind of gases, CO2 is one of them, water vapor is one of them, which has the ability to absorb, and that is what they are trying to highlight. So the most of the molecules which are there in the environment, they do not have any infrared radiation capturing ability, and hence they do not impact the greenhouse part. But there are certain specific gases like the water vapor and the carbon dioxide, they trap heat and they have the greenhouse capability. And carbon dioxide, we have been hearing about it, CO2 and all is the largest contributor towards this. So it's a main culprit when we are talking about that the temperature of the earth is going up. And if you look at the reference that they've given in the CAR book also, despite the fact that carbon dioxide only makes up to 0.0415% of the atmosphere, still it has a very, very strong impact when we talk about the greenhouse effect. Okay, and we're going to be moving towards how the humans are impacting the climate. But before that, I'll just quickly take you towards the book. So what we have tried to cover is this. And in this, there are a lot of content, but those content is not important in the sense there is a general discussion going on, which I have avoided. And I focus more and more on the core part of the content. Let us move towards the next section, which is the 1.5, how humans are changing the climate. And within that, we are going to be first talking about the carbon dioxide impact. Let us go toward that section. And in this case, very, very important study was done by Charles Keeling, and he came out with Keeling curve. And this curve is very, very important from the exam perspective. You can see a diagram in the exam or some reference of this curve talking about the increase in the carbon dioxide. Now, what does this curve talks about? This curve basically gives you an idea what is the concentration of carbon dioxide in the atmosphere. Okay, and they have covered it from the middle of the 20th century till 2022. And we can see that the trend has been an increase. Okay, so the carbon dioxide part per million as a part of the atmosphere, it is going up and up. So this is one of the strongest evidence that suggests that because of the greenhouse gases, which is one of them is carbon dioxide, the temperature is rising. And why is CO2 increasing? Because of the human activity. So we'll talk more about the human activity connection as we move ahead. But in this section, this Keeling curve gives you a long-term view of what is happening with respect to the carbon dioxide in the atmosphere. Okay, and we know, because we have been discussing a lot about this, the climate change and all, that CO2 primarily comes from the combustion of fossil fuels. So when you drive a car, you're emitting CO2. That is one of the major factor. The factories, they are also emitting CO2. They are also the major factor. Now let us dig down more into the specific nature of carbon dioxide. And this part is also important from the exam perspective. So what they're giving in the GAR book also, they're explicitly highlighting that whatever is the carbon dioxide which is emitted, okay, because of the human activity, 44%, okay, on an average is released in the atmosphere. What is happening to the rest? So if we go to this, almost one quarter means 25%, almost 25% is absorbed by the ocean. And this is not a good news for us. Why? Because when it is absorbed by the ocean, it leads to ocean acidification, which is also a problem, which we're going to be talking as we move ahead. But the core point that you want to realize that out of the total carbon dioxide that we are emitting, okay, there is 25%, almost 25% being absorbed by the ocean. Some part is absorbed by the land biosphere, which means there are trees which are there, which are absorbing carbon dioxide, vegetation which are there, they are absorbing, and the rest, almost 50% of what we are emitting is still in the atmosphere. So this is an important point, that out of the total emission that we are doing, 50% is still in the atmosphere. Let us move forward. Okay, so if suppose we are emitting around 10 gigaton of carbon every year, then out of that, almost 5 gigaton will remain in the atmosphere. So this is one indication that we are being able to see that if we look at the total emission of carbon across over the period of time, and we compare what has been the carbon available in the atmosphere. So we see that out of the total, 50% is still there in the environment. So this also signals that the carbon dioxide released because of the human activity is there in the environment. That is the first indication that because of the human activities, the carbon dioxide is going up, and because of which the temperature is going up. The second major reason, which this research told us, or basically highlighted us, is that the specific impact of carbon-12, this isotope over here means a molecule, okay, which we have identified in the atmospheric carbon dioxide. This is very, very specific to a fossil fuel consumption, which basically means if this carbon-12 molecule only gets emitted when you burn, say, wood, or when you do combustion of petrol. So all of this, the fossil fuel, okay, so these fossil fuels are the only ones which are releasing carbon-12 and which we can see in the atmosphere. So whenever we are doing a study of carbon dioxide in the atmosphere, we find that carbon-12. And that is also one of the indication that, oh, this carbon dioxide is coming because of the fossil fuel consumption, which is done by the human activity. Okay, this is the second reason. The third reason, when we look at the ice which was being covered in the North Pole, South Pole, Arctic, and we do analysis, and we are talking about the chemical composition, okay, chemical analysis of those ice, we find that there has been traces of atmospheric carbon dioxide, which is due to the human activity. So this is also third evidence that we have got. And these three evidence, first is almost 50% is still there in the atmosphere. Second, carbon-12 as an isotope, which is only coming because of the fossil fuel consumption. And third is the chemical composition of the ice, which is there in the planet. We have checked and we have analyzed it, and we found that most of the carbon dioxide that we see in those ice is because of the human activity. So these three reasons. And I'll just take a quick pause and I'll walk you towards the section. So Keeling curve is covered over here in the book. And in this section, they've given you a few references of the study, and major discussion is all of this we have covered, okay? But the major discussion is about the isotope and different types of isotope, and they've come to the conclusion that carbon-12 is something which we are slightly concerned about. Further, they've talked about this carbon dioxide is also increasing a lot. The land biosphere is absorbing certain amount of carbon dioxide. All of this we have just covered. Out of the total carbon dioxide being emitted, how much is absorbed by the land biosphere, how much is absorbed by the ocean, and how much is remaining in the atmosphere. So that is covered over here. Now we are moving towards the next section, which is other greenhouse gases. And then there is one more unique, which is aerosol, which is also going to be there in the atmosphere. Okay, and how it is helping us. So if you go towards that, so carbon dioxide definitely is the main culprit, but there's also one more, which is water vapor. Now, water vapor is very strong. It has a very strong ability of heat trapping, and that's why it also makes it more strong candidate for greenhouse gases. But when you look at the GARB book also, and we look at the table, which they've shown you, and they have tried to highlight which gas is having a highest amount of global warming potential. We'll come to that term, but in this table, we don't see water vapor. One of the reasons this is not available because water vapor is a part of the atmosphere and it keeps on going and coming in because of the evaporation of water into and conversion into cloud and again rainfall. So it is a part of the process. So even though it is one of the strongest greenhouse gas, it is not impacting us that much as compared to the carbon dioxide. That has been highlighted in the GARB book. Okay. Now let us come to the concept of what is global warming potential. Now over here in the exam, they might test you on the definition of greenhouse. So what we are trying to highlight over here is what is a heat trapping potential, but we are comparing relative to carbon dioxide. Why? Because if you look at this table, the heat trapping potential of carbon dioxide is only 1. So it becomes a base. And then you're comparing it as compared to carbon dioxide, how much you're trapping the heat. And that will determine the global warming potential of that particular gas. So there are other gases which has a very high global warming potential like halocarbons and all, but they're very small in quantity in the atmosphere. So over here in the book also, they've just given you gist of different gases and what are their global warming potential. Not very highly important for the exam, but the inclusion of aerosol, that is important. Now what aerosol is simply doing, it is actually doing a reverse activity. It is all the other greenhouse gases, they are trying to increase the temperature of the atmosphere, but aerosol is doing ulta. It is actually reflecting the incoming solar radiation back to the earth, back to the atmosphere, space, and because of which what is happening, it is leading to a cooling effect. It is not letting the heat to come inside the earth, and it is just throwing it back. So it is actually creating a net cool effect for the climate. Aerosol, okay? And there is one diagram also given in the GARB book where they have explicitly mentioned, which I'm taking you now. Look at this diagram. They've taken an example. Suppose if you are emitting a total of, suppose because of carbon dioxide and other gases, if you're emitting around 3 kilowatt per million part of greenhouse effect, which is highlighted over here in the first two section, you can see it is almost 3 and this part. And if you look at the net impact, which is the total contribution, okay, it is not very high because there is a important component of aerosol. So they have given you an example also over here, the carbon dioxide and other, if suppose we are taking an example that carbon dioxide and other greenhouse gases, they are leading to about 3 Wm impact, and aerosol has a negative. Can you see in the graph it is going down, because it has a cooling effect. If other greenhouse gases are increasing the temperature, the aerosol is having a cooling effect, and because of which the overall net warming or the net human contribution is getting reduced. So there is some positive news over here for us, and they have given you in terms of the example also. Overall, we can see that because of the 0.75 impact of aerosol, the net human contribution is only 2.25. Even though the greenhouse was having the contribution of 3, the net is lower because of the cooling effect of the aerosol. There is one more important point which they have highlighted over here. Water vapor does not appear in this table, because of its abundance in the atmosphere, and because it is regulated in the atmosphere. When we say regulated, the water is getting evaporated because of the heat, it is getting evaporated and converted into clouds, then it is condensed, and then it again rains. So even though there is water vapor heavily there, but it is regulated because of the internal cycle of the atmosphere. That is why we have not explicitly written down that thing in the table. Okay. The abundance of the aerosol has, over the past 2 centuries, the abundance of aerosol has increased. So we have seen that cooling effect also increasing. Okay. So there has been a growth of greenhouse gases. There has been a growth of aerosol, which is giving you a positive effect in the atmosphere overall. With this, let us move towards the next section, which talks about the water vapor feedback. Before we go to that, I'll just quickly take you toward this section, other gases. Okay, now over here, they have given reference of nitrogen and all of that. This is very specific information, which I don't think so. I have not seen in my exam also being tested, but I don't think so. It will not be tested. This explicit reason being, they are very specific information. It will be difficult for you to remember it. Okay, there's also a discussion on ozone. Okay, ozone is also a very good greenhouse gas in the sense that it absorbs ultraviolet radiation. Okay, and we know that before it reaches to us, it is absorbed, and because of which the humans are not facing that much amount of impact. That is why we say we have a strong ozone layer, which is helping us to protect. But what happens is that if there is ozone within the atmosphere itself, it can help you to reflect back. But because of that, the atmosphere can also slightly increase. The temperature can slightly increase. But the important thing to remember over here is humans, because of their activity, they cannot directly emit ozone. Okay, they cannot directly explicitly emit ozone into the atmosphere. But humans can emit precursor of ozone. Precursor in the sense, there are certain molecules which are getting emitted because of the human activity. When they combine together, it can create an ozone molecule. That is what they want to highlight. And if there is higher number of ozone molecule in our internal atmosphere, it leads to higher trapping of heat. Okay, so when we talk about ozone layer, it is outside our atmosphere. But if we have more ozone within our atmosphere, it will trap more and more heat. That is also an impact. Next, they're also talking about aerosol, which is what we have covered. This is the same table that I've shown you. Okay, and these things are also being covered in the discussion that we talked about. Let us summarize in terms of the water vapor feedback impact. Okay, so the overall main point of this discussion is the warmer atmosphere, which effectively means that if suppose there is an initial temperature in the atmosphere, the temperature is slightly high, because of which what is going to happen, your ice will melt, and because of the ice being melting, your water is ice will convert into water, and if there is more water, okay, the heat will evaporate more water, and when the heat will get more evaporated, there'll be more water vapor in the atmosphere, and we know that water vapor is strong global warming gas. It is regulated in the atmosphere, but if suppose the heat is very high, because of which the ice will melt into water and water will get evaporated, there will be more water vapor and it will increase more heat trapping. Ultimately, it can increase the speed of greenhouse gas or increase the effect of greenhouse gas on us. So if you read this section also, they're talking about an initial warming leads to increase in the atmospheric humidity because of the water vapor getting evaporated, and because of which water vapor itself is getting created, which is a strong greenhouse gas, and which leads to more warming. So it becomes a loop. Okay, and this activity of water vapor feedback loop is having a capacity to even double or triple the amount of warming. That means it's a very strong component which can increase the temperature of our atmosphere. Okay, we call it as a positive water vapor feedback loop, which is also being covered slightly in the further part of the chapter. Let us quickly look at few questions which are connected to the greenhouse discussion. So when we talk about the first question, which of the following gas does not contribute to the greenhouse effect? Does not contribute. So water vapor was one of them. Okay, carbon dioxide was one of them. Now, if you look at the options, see this oxygen and nitrogen. Actually, nitrogen is one of the major component of the atmosphere. When we talk about oxygen and the nitrogen, both of them are major component. But nitrogen is not a very, very strong, or it does not have that ability to have infrared radiation. Why we have not selected oxygen? Okay, because oxygen is a simple molecule which does not contribute, but when it gets combined with something else, it can convert into water vapor or carbon dioxide, and which can lead to a greenhouse effect. So what we are trying to highlight by using this question is that which of the following gas does not have directly or indirectly any impact on the greenhouse effect? That is only nitrogen. Let us move towards the next question. What evidence suggests that increase in the atmosphere of carbon dioxide is due to human activity? Okay, so if you look at all the options, the fact that carbon dioxide concentration in the atmosphere begin increasing, see, this is also a reason, but this is not a direct evidence. We have seen that carbon dioxide is increasing from the 19th century, but when we analyze, it is not a direct evidence, or only by looking at that, we cannot say it is happening because of human. Okay, the analysis of isotopes of carbon, is this the main activity? Okay, there is also the second, this point, or the third point, which talks about the fixed fraction of the carbon dioxide which is emitted, almost 50%. This was one of the first points that we talked about. Okay, and lastly, the chemical composition. So basically, this was my first point in our discussion, second and third. Out of that, which is a strong evidence. If you look at this pointers, the option number C, okay, which suggests the increase in atmospheric carbon dioxide each year is an almost fraction. So we can also check the impact right now, and we can analyze how much carbon dioxide emission we are doing, and out of that, what is the increase in the carbon dioxide. And this is a very strong evidence that because of our emission activity, the carbon dioxide in the atmosphere is increasing. So that is why we have explicitly chosen C. I know this question is slightly tricky because all of the options were there, but the purpose of giving you this question was to help you analyze that in the exam, they will ask you question which is a very strong evidence like that.